Hi everyone. In this video, I'm going to explain the technique of completing the square in a second degree trinomial. That is to say, if I have the trinomial ax squared plus bx plus c, I can write it as a perfect square plus some number. So our task here is to convert it from this form into this form. First of all, before I explain how do we do that, we need to know where do we use this technique. Well, we use it in several places. For example, in solving quadratic equations, in writing a quadratic function in the vertex form, and in writing the equation of the circle in the standard form as well, as you will see in the couple of the next videos. We also use it in some techniques of integration, as you will see later in the series of videos on integral calculus. So let's start with example 1. So we have x squared plus 6x plus 2. First of all, we have to make sure that the coefficient of x squared is equal to 1, which means the leading coefficient has to be 1. Otherwise, I will show you what to do in the next example. Then, I always copy the first term and the second term. Now, before copying the third term, I have to add a couple of terms here. Now, in order to convert it into a perfect square, we have to use one of the following identities. Either a plus b squared is equal to a squared plus 2ab plus b squared, or a minus b squared is equal to a squared minus 2ab plus b squared. So we're going to regard the first term as a squared and the second term as 2 times a times b. This means the third term must be b squared. And this is always how we do that. So if the first term is a squared, which means x squared, this means we conclude that a is equal to x. So our next task is to find b, because b is the missing term here. How do we do that? By using the second term. So the second term, which is 6x, is equal to 2 times a times b, and we already found a to be x, which means b is equal to 3. So the third term, which is b squared, will be 3 squared. And of course, it is plus b squared. We always add a plus. Why? Because if you look at both formulas, in both formulas we have plus b squared. But wait a minute. Can I just add any term like that in an expression? Of course not, because the expression will change. So in order not to change the expression, we subtract what we already added. So we end up with x squared plus 6x plus 3 squared minus 3 squared plus 2. Let's copy it here again. So it is x squared plus 6x plus 3 squared, which is 9, minus 3 squared, which is again 9 plus 2. Now the first three terms will be converted into either a minus b squared or a plus b squared, depending on the first sign. So the first sign is plus, which means the first three terms are factored into x plus 3 squared, and this is the perfect square we were looking for. What about negative 9 plus 2? That is simply minus 7. So finally, x squared plus 6x plus 2 is equal to x plus 3 to the power of 2 minus 7. Now what if the leading coefficient is not equal to 1? We mentioned in the beginning that in order to apply completing squares, we must have the leading coefficient equal to 1. So what do we do here? Whatever the leading coefficient is, we factor it out. So we are left with x squared minus 5x plus 3 becomes 3 over 2. Now in this expression, we are able to apply the completing squares technique. So we repeat the same scenario. So we write 2 into x squared minus 5x. Again, we write the 3 over 2 here because we're going to insert two terms in the middle. How do we do that? So the first term is regarded as a squared, which means a is equal to x. So always remember, our task is always to find a and b. Now the next term is 2ab, which means 2ab is equal to 5x. So 2, what is a? It is x. So 2 times x times b is equal to 5x. We divide both sides by 2x in order to isolate the b. And finally, b equals to 5 over 2. This means that we have to add b squared and subtract b squared. That is to say, plus 5 over 2 squared minus 5 over 2 squared. So this expression becomes 2 into x squared minus 5x plus 5 over 2 squared, which is 25 over 4, minus 25 over 4 plus 3 over 2. So the first three terms form a perfect square, and that is equal to 2 into, so the first three terms are just a minus b squared, so x minus b is 5 over 2, so x minus 5 over 2 squared. Now we just have to add these two terms, which means I have to find a common denominator. So I multiply up and down by 2, and this becomes negative 25 over 4 plus 6 over 4, which is negative 19 over 4. Now you can either keep the 2 like that, or you could redistribute it again, which I will do. So this becomes 2 into x minus 5 over 2 squared minus 38 over 4, or 19 over 2. And that's the story of completing the squares.